Good day, my name is Ouyang Zhongcheng, and the presentation is to share with you the details of my data mining project, which focuses on hotel booking cancellation prediction, a topic that holds immense value for the hospitality industry. Cancellations are a significant challenge for hotels, affecting both revenues and operational planning. By predicting whether booking is likely to be cancelled, hotels can optimize their resource allocation and minimize financial disruptions. The objective in this project was to create a predictive model that achieved this with accuracy and reliability. Using historical data as our foundation, the dataset I work with including nearly 120 million records from cities and resort hotels covered booking making between July 2015 and August 2017. Each record detail various attributes for booking such as lead time, deposit time, and special requests, and etc. These diversities in features make a dataset both rich and complex, offering plenty of opportunities but also representing some challenge. The first step in my journey was to thoroughly understand the datasets. The data reveal a mix of numericals and categorical variables. Some columns such as children, country, and agent have missing value, while others like the average daily rates contain noisy data. For instance, I encounter negative value for the ADR, which do not make logical sense. Similarly, there are records indicating booking without any adults, which require closer examination. These anomalies highlighted the importance of data preprocessing in ensuring the integrity of our analysis. To handle missing value, I applied different strategies. For column with no missing percentage, I inputted value based on the mode or mean, ensuring minimal distortions to the dataset. In contrast, column with significant missing value like company, job picked after careful evaluations of their relevance to our goals. Addressing noising data was another critical step. For example, I replaced the negative ADR value with the means, and the record showing zero adult are treated as data entry errors and removed it. Additionally, outliers in column like children and baby are identified and excluded from the dataset. This step ensured our data was clean and ready for analysis. For categorical variable, I use encoding technique to make them machine readable. Nominal variable like the type of hotel or meal plans are one-hot encoded, while ordinal variable are labeled encoded to preserve their inherent order. These data preprocessing steps are significant for preparing the dataset for model building. Then I remove features that are directly related to the target variable to prevent data leakage and ensure a fair evaluation of the model. Next, I drop irrelevant features that do not provide any useful information for predicting the target variable. With the data cleansed, transformed, and feature selecting, I moved to the model building. I implemented several classification models, including decision trees, random forest, logistic regression, XGBoost, and etc. Then tuning the hypermeters and get a more ideal model. To ensure fair evaluations, I prioritize matrices that reflect the nuance of our problem. While accuracy was considered, our primary focus on the F1 score as its balance, precision, and recall, particularly in the context of identifying cancellations. What's more, I also do the example learning to see whether it can better our models. From my first vision prediction, the example learning, which combined the strengths of random forest, XGBoost, and decision tree model, emerged as the best model, achieving accuracies of 86.22% and F1 scores of nearly 80% and AUCs of 85.71%. The ensemble approach allows us to leverage the strengths of different algorithms resulting in a more robust model. The random forest classifier came very close with an accuracy of 86.18% and F1 scores of 79.95% and an impressive AUC of 92.84%, indicating its ability to distinguish between cancellations and not cancellation effectively. XGBoost follow with an accuracy of 83.14% and an F1 scores of 74.28%, showing good performance, particularly in identifying the cancellation patterns. The decision tree classifier, while a simpler model achieved an accuracy of 81.21% and an F1 scores of 70.4%, providing a solid baseline of comparisons. Model 9 logistic regression and K-nearbot classifier performed reasonably ill but didn't reach the same levels of accuracies or predictions as the ensemble method. On the other hand, naive Bayes struggle with the complexities of this tag as indicated by its lowest accuracies and F1 score. Looking deeper into the results are also analysis the feature important, which give us valuable insights into the feature-driven cancellation. From the random forest model, the key predictor including lead time, which refers to the time between booking and arrival, deposit time, no refund as no refundable booking are less likely to be cancelled, and ADR, which indicated the average daily rate and its relationship to cancellation likelihood. Other important features including the numbers of special requests and previous cancellations are also be observed. On the XGBoost side, features like require car parking spaces, market segment like online TAs, and again, totals of the special requests emerge as influential factors. These features, along with other, help us understand what drives the cancellation behavior, and this understanding provides an actionable insight for the hotels. For instance, hotel could flag bookings with known lead time and no refundable deposits at high risk, allowing them to proactively emerge with customers and reduce cancellations. Similarly, guests with a history of cancellations or multiple space requests could be identified and approached with targeted communications and incentives to retain their bookings. By using this insight, a hotel can make data-driven decisions to optimize their operations and improve their revenues management strategies. In conclusion, my project demonstrates how machine learning model can effectively apply to predict hotel booking cancellation with high accuracies and precision. By combining the strategies of different models, we can get a high accuracy model. Moving forward, this is potential to enhance this model by incorporating external data such as local events or economy chain, and by deploying them in a real-time hotel operations. This will allow hotel not only predict cancellation more effectively, but also to optimize their strategies and provide a model customer experience. Thank you for your time, and that's my presentations on my data mining projects. Thank you very much.